to go through the new unit. I asked you to go through the new unit, that is electricity and magnetism. Last time I told you that this unit is one of the topics that are taught in primary 7 first term. In first term, P7, we look at the skeletal and muscular system. We also look at electricity and magnetism. And then the third topic that we look at in P7 is energy resources in the environment. Those are the three topics that we look at in first term. And then second term, we have the respiratory system, not even respiratory, but excretory system. Then we have light energy. And then we also have machines, simple machines and friction. So those ones are for second term. Then for third term, we have tree growing practices, that is agroforestry. And then we have controlling and managing changes in the environment. So all that we look at in third term. But as you know, primary 7, we don't wait until it is third term. We cover all that work by second term, it should be done. Then third term will strictly be revision. So these are the units that we have for primary 7. These are the units. Last time I told you that you would go through machines, matter and energy as the next unit, but I realized that it had missing work. There were diagrams which were missing and the work was jumbled. So what I did was to create, I had to create another unit. I had to create another unit, and which is the same, but it is now, it is very clear here. It is reading simple match, it is reading electricity and magnetism. So I need you to continue with this unit, electricity and magnetism. Don't continue with matter and energy, because this one I realized it is jumbled. It has some diagrams are missing, like that, like that. It is the same work inside, but then for the case of this one, it is organized. I'm going to remove this other unit because I've already replaced it with this one. I'm going to remove this one, then you will continue with this one. So I first want to hear from you what you're doing throughout. So you realize that this one has now the diagrams that we need, all the diagrams that we need. They are here. All the diagrams that we need just here. But the other one had no diagrams and it was jumbled. So that is it. So this is the new unit and it is wide. You need to go slowly, slowly. And I want you to write the work systematically. As you can see mine here, it is very organized, very, very organized. Even I realized that even the first unit that we looked at, that was the muscular and skeletal system, it was also having some issues. So we shall still be, for the next unit that we shall look at, we shall have to go through it first and make sure it is okay for you to write down the work. So that is it. Let me hear from you. How have you been doing?
I'm okay. Actually, I'm not being able to, none of the units are actually loading of the site. So the loading the units, I guess.
I didn't hear you well.
But the units aren't loading in the site.
How long has it taken?
Since a very long time, I guess. Okay, since the last time in the morning they weren't loading.
Yeah. That's bad. That's bad. But I think by then we had the we were just updating the work in the site. That's why maybe you found those difficulties. But right now it is going to work. If you try to log in, it will work right
Okay.
now. So it is okay. So since you didn't go through that work, so you've
But
now
no,
seen.
I had gone through it using
Okay.
one of my textbooks.
Using some of your textbooks.
Yeah.
Okay. Maybe we can share that, but I want you next time the textbook should be just to supplement, to add on whatever you do. But most of the work, all the work, you must be able to follow from here. Then what you don't get very well here, you can supplement. You can read the textbook and also this one, because these ones are summarized. It is easy for you to go through. Maybe let me first hear from you. What did you try to summarize about electricity and magnetism? Then we can go through this work briefly. Then I will set you free so that you can try to log into the site and go through this work. This one contains all the diagrams. The work in the textbook is very shallow. It doesn't contain everything, but this one contains everything. So let me first hear from you how far you went forward.
According to what you've shown me, it's I went through the same work. I did a bit about electricity, types of electricity. We have current electricity and static electricity.
Maybe you can tell me what is electricity.
I looked at atoms. So according to what I've written down, electricity is a form of energy, and it is found in every form of matter. Electricity is formed by the flow of electrons, and the electrons are negatively charged.
Okay, now Shivani, when defining electricity, you will simply say there are two ways of defining electricity. You'll simply say electricity is a form of energy, just as you started, is a form of energy produced by the flow of electrons. But then when you continue, when you look at the types of electricity, you realize that there are two types of electricity. We have static electricity and then current electricity. So when you look at static electricity, you get to realize that this is the type of electricity where electrons do not move. Electrons do not move. Then for the case of current electricity, electrons move. And yet, when you look at the definition of electricity, we are saying that it is a form of energy produced by the flow of electrons. So you realize that it seems we are defining only current electricity, leaving out static electricity. So there is a short way that we shall have to adopt a new way of defining the term electricity. We shall simply say electricity is a form of energy. If I can type it here, electricity is the form of energy produced by produced by charged particles. Produced by charged particles. Produced by electricity is a form of energy produced by charged particles. Full stop. So this is what I want you to be having. But however, in our notes here, because all the textbooks, all the books are saying that is a form of energy produced by the flow of electrons. All the books. But then because we have now research, we continue doing research every time. So we realized that when you look at the types of electricity, not all these types of electricity involve the flow of electrons. They don't involve, not all of them involve. It is only current electricity which involves the flow of electrons. While for static electricity, electrons do not move. So it will be wrong for us to say that electricity is a form of energy produced by the flow of electricity. And yet, in static electricity, the electrons do not flow. So that is why we came up with this, and very soon we shall be changing the textbooks also. We shall be having electricity is a form of energy produced by charged particles. As simple as that. That is electricity. So that when you continue ahead, you look at the types of electricity, whereby you will talk about static electricity and current electricity, whereby static electricity is a type of electricity where electrons do not move, while current electricity is the type of electricity where electrons move. As simple as that. And then you continue and continue like that. So when you look at the examples of static electricity, you get to realize that even those ones are two, but the books mention one. Static electricity, an example of a static electricity is lightning. But there are two. The other one is a statically rubbed particle. So all those things are here. They are just here. So next time, as I want you to start this unit afresh, you'll write it systematically, neatly. I will need to check even your books one day if I get chance. I need you to write it neatly, starting with this arrangement. Matter. So what is matter?
Matter is anything that has weight and occupies space.
Good. What is energy?
Energy is the ability to do work.
So that is P5 work. So forms of energy.
Electric energy, sound energy, heat energy, light energy, magnetic energy, solar energy, chemical energy, mechanical energy.
Mechanical energy. Can you give some of the examples or the types of mechanical energy? Types of mechanical energy. This is what we learn in primary 5. In primary 5, we look at the types of mechanical energy or examples of the mechanical energy. Do you know them?
No.
This is kinetic and potential energy. So the types of mechanical energy include kinetic energy and then potential energy. What is kinetic energy?
Kinetic energy is a type of energy possessed by moving objects.
Very good. Then potential energy.
Potential energy is the type of energy possessed by object at position.
At rest.
At rest, yes.
Or if you don't want to use the word at rest, you will say possessed by stationary objects. As simple as that. So when you're doing your work, you'll also get these questions here. The first question says state the two types of energy. You'll mention them. Mention the three states of matter. You'll mention them. In which state of matter are molecules spacious? In which state of matter is this? Are molecules spacious?
In gas.
Good. Good. In which state of matter are molecules tight?
Solids.
Good. In which state of matter are molecules mobile?
Liquids. I'm not sure.
It is still gas. It is still gas because they are spacious. So the molecules are mobile. Then immobile?
Solids.
Immobile, it means they don't move. They are packed together. They don't move because they are tight or they are packed together. Those ones are solids. Those are solids. In secondary, by the way, you're going to go to
Yes.
secondary and they will ask you these things. What is a molecule? What is an atom? What is an element? So you must be able to know all those things. Even matter, they ask you in chemistry. So this part here we are looking at is the chemistry part, but then electricity is also for physics, but this particular part is chemistry. So what is a molecule?
A molecule is the smallest visible particle of matter that can take part in a chemical reaction.
That can take part in a chemical reaction. A small particle, smaller particle of matter that can take part in a chemical reaction. So you need to understand these things here so that when you get there, it is just a walkover. It will be repetition. Then an atom, what is an atom?
An atom is a
Sometimes teachers say, look at this smallest atom here. They can even refer to a youngest child or smallest child as an atom, meaning that one is the smallest of all. So what is an atom?
An atom is the smallest visible particle of matter that can take part in a chemical reaction.
So the difference between the definition of a molecule and the definition of an atom is, for the case of an atom, this one is the smallest and cannot be divided. Smallest and cannot be divided. Right. That's why we said here that an atom is the smallest indivisible particle of matter. Smallest indivisible particle of matter. Smallest indivisible particle of matter that can take part in a chemical reaction. Then for the case of a molecule, this one is a smaller particle of matter, meaning a molecule is bigger than an atom. A molecule is bigger than an atom. So when you continue, you realize that an atom has got three parts where we have electrons, protons, and then the neutrons. As simple as that. So this is what you need to know. So you will have to draw even that. You will have to draw an atom. So with electrons, these are negatively charged particles of an atom. Then protons, positively charged particles of an atom. And then for the case of the neutrons, this one is the neutral part, neutral particle of an atom. So this is what we are talking about. So those ones with the minus, those ones are electrons. And then those ones with the plus, those are protons. And then the nucleus is that middle part, which contains both the protons and then the neutrons. And then we have the neutral part. Those ones without anything. Those ones are the neutrons. Those ones contain the neutrons. Those ones without anything, those are neutrons. Okay, so this is now electricity. So even me, I'm going to change this definition of electricity because not all types involve the flow of electrons. Not all types involve the flow of electrons. With static, it doesn't involve the flow of electrons. So that is why we shall be using the other one. And in fact, when you're writing, you'll write this definition because it is still in the books as we are trying to produce other books. So you write this one, and then you can also put there, or electricity is a form of energy produced by charged particles. Just the difference should be produced by charged particles. You include it also here. So these are the forms of electricity or types of electricity. The good thing you already read about this. So these are the types. Static electricity is there. Static electricity is also called a frictional electricity because it is produced by rubbing two surfaces together. Examples of static electricity: lightning. When you're spelling the word lightning, you don't include here letter E. Are you seeing where my cursor is pointing?
Yes.
So don't include there E between T and the N. Don't put E. Don't put E. So lightning is without that E there. So you'll have lightning, then the other one is a statically wrapped insulator. Those are the two examples of static electricity in nature. At school, you can be given to just rub, you rub just your pen over your hair. Just rub the pen with your hair until you feel some heat. You rub, then you of course, when you're rubbing, you should be having some pieces of paper on the desk or on the table, which you've already cut into small pieces. Then you rub the pen on your head or anything. You rub it when you feel some heat, and then you put that pen over the pieces of paper. You'll see that pen attracting those pieces of paper. That is what we call charging something, charging an insulator, a statically charged insulator. So this one also we shall say statically charged insulator. Instead of rubbed insulator, we shall change this word to be charged insulator. I will have to go through that from the back end, and then I change that. So that is what you need to know. Then characteristics of static electricity, they are here. Can you go through them?
It is temporary or short-lived. Electrons do not flow. It occurs in insulators only. Both protons and electrons are all active. Electrons are on the surface of the insulator.
Electrons are on the surface of the insulator. As simple as that. So this is all what you will be doing. So this is what I was talking about. You can rub that thing on your hair, and then it will attract those pieces of paper. You will try that as you're doing your work. So observations, you'll get this. When the plastic comb is placed on the tiny pieces of paper, the pieces of paper are seen getting attracted to the plastic comb. Why? After rubbing the plastic comb on the hair, it gains electrons that attract the tiny pieces of paper that have got the protons. The reason why that comb attracts the pieces of paper, because it is charged. You just give a short answer and say it is charged. It's because it is charged with the protons and electrons. Then lightning, this is an example of static electricity in nature. They like asking, name anyone, name an example of static electricity in nature, or name an example of frictional electricity in nature. Simply say that is lightning. That is lightning. Effects of lightning are here. Maybe you can go through them. What are the effects of lightning?
Lightning can cause death or human beings who are struck by it. Lightning can set fire that can burn bushes, houses, plantations, buildings, etc. Lightning causes damage or death of livestock and wild animals. Lightning can cause damage in electric appliances such as radios, televisions, transformers, computers, etc. And many others.
And then we also have the importance of nitrogen, importance of lightning, and so on. So all this, you look at them. Precautions or measures to be taken against lightning. If you don't want to be affected by lightning, what do you do? Avoid being at the highest point during a thunderstorm. Never walk on barefoot in an open area during thunderstorm. Avoid any contact with water pipes during thunderstorm, because pipes can conduct lightning current. Do not take shelter under trees during thunderstorm because lightning may strike a tree and kill you. Avoid swimming or crossing rivers during thunderstorm because lightning can be conducted by water. And then buildings and tall trees near buildings should be protected with lightning arresters or conductors. So in fact, if you want to control or protect your building, your house with against lightning, you must be able to put a lightning conductor on your building. Fix it on your building so that it will continue to arrest the lightning. So this is what we are talking about. This is what we are talking about. This is the lightning conductor. It is here. In most cases, you will see it as a musalaba or cross. You will see it as a cross on top of the building. Its work is to prevent lightning from damaging the building. And then after that, you will also have some exercise you write on the book, and then you answer all those questions. The exercise is not difficult. How is static electricity formed? It is not difficult. Name the force that helps in the formation of static electricity. Maybe I can ask this, only that we have not yet discussed this. The good thing you read this. How is static electricity formed? Do you know? Shivani? How is static electricity formed?
Static electricity is okay. I didn't read about static electricity.
No.
Because according to my book, they first did current electricity, and I just finished writing about static current electricity. But according to what I read, when objects rub on each other, something like that.
That is true.
Formed when
insulators are rubbed together, then static electricity can be formed. So when they ask you, you can simply say it is formed by rubbing two insulators together. It is here. Static electricity is a form of electricity in which electrons do not flow. Then the second statement. Static electricity is produced by rubbing two insulators together. And then you continue. Friction force helps in the production of static electricity. As simple as that. So let's continue. You will see that all those questions are asked here. So I want you to start that unit afresh so that you will be able to answer these questions, all of them. You answer, you write them, make sure you're able to access this work. The moment it fails, put in the group.
Okay.
Someone will call you very fast to help you. The moment you fail to access work, don't wait for the whole week to get wasted. We have a lot of work that we need to complete. So here, how is static electricity formed? You simply say by rubbing two insulators together. Name the force that helps in the formation of static electricity. You simply say friction force. How is lightning formed? So all these questions are there. So if you write the other work, you will be able to answer all these questions. As simple as that. And then after that, you will start with current electricity. We'll start with current electricity. So all that. So that is what I wanted to show you so that you can go through that work. It is wide. That work is big, but you'll keep doing what you can slowly until we finish. Even though we take like 3 weeks, it is okay. And the most important thing is you writing that work very well. And then you keep asking questions where you don't understand. So that's it from me. I don't know if you have any question, you can ask. I want to leave you with these remaining minutes for you to try and log into the site and probably put that work. Try to write it systematically down.
But I'm also planning to print this work out.
You want to print this work?
Yeah.
There is no way you can copy this work. It cannot be copied. This one cannot be. So if it was easy to copy, to print, it would be possible, but you cannot print it. It cannot
It's easier for me to print.
I don't think you cannot manage printing that work. This very work here. Because this one cannot be copied. If you try to highlight, you cannot.
Okay.
So the only way to go is to keep writing slowly. It needs a lot of time, as if you are at school, as if it is a school time, because you have all those other subjects. You have maths, you have English, social studies, and also science. So it means that you need to have a timetable, working timetable, which will keep you busy throughout the day. But as long as you don't have that timetable and you feel...
I have a timetable.
Okay.
I'm following a timetable.
Okay, that's good. That is good. So that is it. I want you to do this. Then after, we shall also choose another unit that we can look at if we finish this one. But I want you to move slowly, keep writing what you can, and then you come and present, and then we discuss, you understand, and then we move to the next level. So that is it. So if there is anything, you can ask if you have any question.
I don't have any question.
Okay.
But I will ask when I have.
Okay. So what I was saying, you need to now try to log into and see if you can access this work.
Okay.
Okay. So have a good day and a nice week.
Me too.
Okay. See you then.
Okay, bye.
Okay. Yes, we are done with the lesson. So I think you can end it. Have a good day.